ICS SCADA system. We looked last time at the different component and architecture of the ICS SCADA. Okay, and we said that the ICS SCADA is the main thing that will control what is happening in the field. Okay, when you have sensors and they are sensing some and collecting data, sending that data to the controller. Okay, those people will analyze data and will send controls to do some action on the field. Okay, and everything is done at that ICS or SCADA system. One of the component, the main component, which is known as a master terminal unit or the MTU. Okay, it is this where you do have that computer. Okay, that is part of device of the ICS SCADA system, where you do have, for instance, you can have specific computers that have been dedicated for the specific purpose. You can have what is known as a programmable logic controller, or you can have servers that will communicate with what is known as a remote field RTU. Okay, and we looked at this is where you do have that master terminal unit, when you do have those people controlling what is happening in the field. Okay, getting some aspect of data analysis graphs, and they will take action based on that one. And I think we already explained this one. You do have that programmable logic controller, PLC or RTU. We said that these are RAG specific industrial computer. These are specific computers that have been dedicated, that can be placed in industrial environment, okay, with the pre-installed instructions, okay, that are installed in their memory, and based on the data they receive, they can take action. They are connected to some devices like sensors, for instance, and based on what they are receiving, they will proceed. We will talk about programmable logic, where you do have some logics inside that PLC. This is an example. It's an intelligent electronic device where it can take action on itself. It doesn't wait for the command to be sent from the MTU, from those people who are behind the screen. So it can take action based on some logic input. It does receive some input and it do some logic operations and gets you the output, decide what will happen. In terms of the RTU, this is an RTU or a remote terminal unit. We said that it gathers information from those different types of, for instance, sensors, actuators on the field, in the environment, okay, and that the information can be sent to the MTU, where it will get the command that will trigger, for instance, some and control some actuators. This is an example of an RTU. This is another types of RTU that you can find in the radio RTU, cellular, and serial. I think we stopped at this is another example where you have an RTU receiving data and sending data to the control room. The control room will send back a command. Then that command will be triggered by that RTU to do some types of action on the devices that are in the field. We looked at the equipment, communication equipment. We said that we do have various types of communication between the RTU and the MTU, the control center. Okay, here we talk about the RTU in the field, and you do have the MTU in the control center. So this communication can be wireless, can be wired. You can use cables, twisted pair, metal fiber, optic, satellites, high frequency radio, all the types of communication, whether it is wired or wireless. And we said that the topology of the SCADA network is based on the type of application it is done. But we talk about redundancy topology. It is recommended. Okay, like here, you can see here we do have some types of data. This is wireless SCADA, where you do have, for instance, a primary database and you do have a secondary database. We do have HMI primary, we do have HMI secondary. We do have redundancy here. In case of one of those is compromised or fails, at least we do have another replacement. And this data in the field, you do have some sensors, for instance, okay, where you are gathering information. you send that data to the PLC RTU. RTU PLC will send data to through satellite, cellular radio, wireless communication to the network where you do have the database. And these are the devices that can be found in the MTU, Master Terminal Unit, where you do have people controlling the data, then sending back some command. These are the field instrument in terms of the ICS. You do have field instrument where you do have many types of devices that can be found in the field, in an environment. Okay, you can find sensors, you can find a valve, pumps, pressure sensor, temperature sensors. These are the field instrument. This is what you find inside an environment. Okay, and those devices or those field instruments are there to collect some specific data in order to do later analysis. We send that data to that PLC RTU. On its own, it will be sent to the control room, analyze the data, send back some command that will trigger some devices. You do have that actuators, okay, and these very important devices that are responsible for making action to the surrounding or the attached environment component. Like I told you last time, if you remember the example we gave, you are monitoring the level of a barrage and by sensors, and you find that the level has reached some threshold, so you need to open a valve. Who is going to trigger that action and open the valve is the actuators. Actuator will receive the command, and because he is connected to that valve, he will trigger an action, whether it is a mechanical action or electronic action, to open or close. Okay, so they will receive, as we mentioned, they will receive commands, and they can be controlled from the control room in the ICS SCADA, okay, remotely, because they do have the capability of receiving commands and triggering something that is attached to those actuators. And they are very important devices. Another component that can be found in as an architecture of ICS SCADA is the software, and this is very important component in the architecture of ICS SCADA, because without the software you cannot do anything. So here you do have software running all those in the SCADA system, where we said you do have dedicated computer. That means you do have some specific operating system that will control some other computers, hardware. They are used in communication management, for instance. They will generate graphical interface to the user. All those software. This is an example of the software that can be used in the control room. Okay, where you can see here you do have many options. You can display any types of device. You can see their graphs, and you can send commands to those devices in the field. Okay, it might generate an alarm. It can record as well. Okay, you can record the event that are happening, or the collected data, or the live collected, the real live collected data also can be recorded. Generate some graphs, live graphs. It's like, for instance, like when you have a graph of shares. Okay, the share as up and down in their price. So you will have live data. You will have a live graph, and the same thing when you are controlling some specific field. Okay, specific. For instance, I'm looking controlling pressure, temperature, or pressure, or temperature, or whatever you are controlling. You are receiving real data, and you can see that data in real manner with a nice graphical interface. So you can spot any anomalies in the reading of the data. So you can take action based on the analysis you do, and you take action. Then you send your command to actuators to trigger something, whether mechanical or electronic, in electronic way. So these are the main architecture components that can form an ICS SCADA system. Now, the main thing is in any types, what we are looking in ICS SCADA security is, for instance, what are the different vulnerabilities? Why we do have such vulnerabilities in an ICS SCADA system in order to understand what can happen and how we can, let's say, secure the ICS SCADA. If you remember, we said that the ICS SCADA is very important, specifically for those critical infrastructure. When we gave an example of smart grid, we said it is very important to secure such environment, such CPS environment. And that CPS environment is controlled from an ICS SCADA system. That's why it is very important to protect that environment. So now we say why we do have vulnerabilities in the SCADA system. There are many reasons. The appearance or the presence of vulnerability in the ICS SCADA system. One of the reasons is the absence of, let's say, a scanning real-time network, because we said that we are receiving data in real time. So sometimes you do have a lack of detecting suspicious activities within the real data. It's not like when we do have, for instance, log file that you can later look at that log file and analyze the log file for any abnormalities within the log files. However, when you receive real time, it's not easy to spot, to analyze the real time data. So this is one of the factors that make the vulnerability of the ICS prone to many that can be exploited, and some unusual activity cannot be spotted because of the lack of the real detection of suspicious activity. Another factor that contributes to the existence of vulnerabilities in the ICS SCADA is how you identify the threats. Okay, identify threat and react accordingly. As we mentioned, it is not easy to detect and identify any threats in ICS because it is a complex system. You do have embedded system, one system inside the system, so it is not easy. It is done, but it is not easy, and it cannot be done on every ICS SCADA system. Sometimes the slowness for updating the system, okay, because someone who has, let's say, didn't take action or didn't update the system in the appropriate time, that means that has been the cause of the presence of the vulnerability. Sometimes you don't have an idea about the type of the traffic you are receiving, because those devices are old devices, for instance, okay, and you don't have, for instance, those people who are specialized, they don't know how, for instance, to differentiate between any abnormal activity with a normal activity, specifically in the field instrument, with their different types of devices of those field present in the field instrument, okay. And sometimes you do have some neglected and unskilled people, okay, because you do have people who are working in the ICS SCADA system. They are not security peoples. They don't abide to some security policies, for instance. They don't have experience, okay. That means they are giving a chance to the attacker to gain access and use and exploit that, let's say, the action of those unskilled workers working in the ICS SCADA system. In terms of the attackers, okay, we talk about the threats, why those threats can be found, and for the attacker that are targeting, for example, that is targeting the ICS SCADA, we said that it is not done in one trial. That means someone who is trying to go through an ICS SCADA system, the action will not be done only once, okay? Because if that ICS SCADA system is secure, that means you will find people who will try, for instance, at the beginning to access the ICS SCADA. If they fail, they will keep trying. They will keep trying until they get and achieve their goal. That's why we said that the type and the complexity of attacking methods is determined by how an attacker is determined to achieve his goal, how much the attacking purpose is vital. For instance, if you do find someone who is who just tried to access ICS SCADA, maybe he will do it once. Okay, he will not do it in many trials. But however, if you do have a determined person who determines attackers who wants whatsoever the price to get inside the ICS SCADA, so they will keep trying until they achieve their goals. So that means the attacking method is based on, it depends of how much the attacker purpose is vital, what impact level must be achieved to satisfy this purpose. Okay, in order, for instance, if I want to make down a smart grid, okay, that means it will have a big impact on achieving or making down a smart grid plant, for instance. And also how much that system is secure. Okay, it depends of the security that can be found in the target. If that smart grid is secure enough, that will prevent anyone from getting access to the smart grid field. That means the attacker will maybe just DOS will be enough for him. Okay, just to slow down or to freeze the servers in the smart grid environment will be enough for them, because they couldn't, for instance, get access or physically or to break down the devices. Okay. We said that last time. We talk about operational process, because we are talking about a ICS SCADA. We are talking about devices that can be that run in a mechanical way. Okay, that means you need, for instance, you need to shut down. If you want to close a valve or to open a valve or to turn off an AC, that means you need to manipulate the operational process. Okay, how the process is operating within that field. If you want to close a valve, you need to understand how the valve can be closed. For instance, in order to achieve your, let's say, most damage and harm the structure, for instance, with equipment, with human, or whatever. So you need to manipulate. That's why we say we need, in order to distract an ICS SCADA, it's not enough to launch a cyber attack only. So you need to manipulate also the operational process. The cyber attack will, let's say, will be the first thing in order to follow with the operational process. That means you will stop the process, you will increase, will decrease, whatever the process you are targeting, you need to harm that process. Okay, it's not a way, for instance, I have infiltrated remotely inside that ICS SCADA system, but I couldn't stop, let's say, nuclear generator, for instance. Plus, if you cannot do the objective, you cannot play with the process, the operation of the process, that means you did only half of the attack. Okay, because your objective is to turn off, for instance, that nuclear generator, to turn it on, for instance. So this is related to the operational process of that specific device. In terms of the types of threats that can be found in ICS SCADA, we do have two types. We do have unintentional and purposeful threats. Unintentional, that means someone who is, let's say, a threat that is not mainly, say, done in purpose. Okay, for instance, you can find someone based on the errors, maybe someone who has less experience. Okay, he neglected, for instance, to it's like what we have, what did in Stuxnet in Iran, a nuclear plant. Someone, for instance, because of the carelessness of that guy who has used USB brought from the outside, he used it inside that nuclear plant, and it resulted in hacking of that plant. And this one of unintentional, because we said that that guy, he didn't do it in purpose, because of his neglecting and carelessness of what can happen, and we talk about lack of knowledge. He doesn't know, for instance, let's say, the danger of bringing something or using external USB or plugging that external USB into a computer that is part of the nuclear plant. This was, let's say, one of, let's say, the threat that can be found. You can sometimes find failure of the device themselves. We do talk about machines failure. As we have said last time, any machine has a life, okay? And sometimes you do have the machine itself has broken down because it is an old machine, or it does have some problems, okay, which lead to the device to be shut down. And this can be also considered as an intentional threat. Or you can have something that's related to the natural disaster. Sometimes you have landslide, avalanches, earthquake, volcanic eruption, flooding, tsunami, whatever. These are part of the natural disaster. This also, it is an intentional. It is not done on purpose by someone. We talk about on purpose. The second type of threats, which is the purposeful threat. These are the attack or threat that are done by someone, okay, who has intention to damage that ICS SCADA system. You can find someone who is an employee who is not happy about his salary, or he has a problem with his manager and he wants to take revenge. So he will just do something that will harm the ICS SCADA. You can find the cyber hackers, industrial espionage, viruses, and all the stuff that are done on purpose. These are known as purposeful threats. The challenges, now, if you want to protect, or you have an idea, or if you have an objective of protecting an ICS SCADA, there are many challenges that can, say, can stand, let's say, against your will to protect that ICS SCADA. One of the challenge is you are trying to secure an ICS SCADA that has an old architecture design. Because if you remember what he said, we are talking about CPS environment. The CPS can be an old plant, old factory, industrial factory, okay, that has machines that dated, let's say, a decade or 2 decades ago. And when those machines, they don't have any aspect of security, the design of that factory is an old design. It is not based on security design. That means it is a challenge for you to secure such plant or such ICS SCADA. Sometimes you do find within an ICS SCADA the messages that are exchanged between the different devices, whether from the field device to the MT to the RTU, from RTU to the MTU. It is not encrypted. It is sent in a clear text. This is another problem for you to secure. Maybe the devices that are part of that ICS SCADA system, they are not compatible. They cannot they cannot use latest, for instance, encryption technology because of the limitation of their hardware, for instance. Sometimes you do have a problem with the unpatched operating system and applications. This is a challenge. That's why you cannot, for instance, you do have a problem in securing ICS SCADA. And even the same thing as we mentioned related to the old devices, maybe those old operating system running on old devices, they cannot be updated with new patches that will defend against the new attacks and new viruses. Okay, and the problem is how to secure the remote devices component, which are geographically scattered. They are put in everywhere in environment, like sensors, actuators, PLC, RTU, and they are remotely, and they can be accessed by anyone in a specific field or area. Of course, there are other management, civil management, and operational technical challenges that are related. We list for them vulnerability tracking problem. It is not easy to track the vulnerability of the devices used in the ICS SCADA system with different machines, with different hardwares, with different operating systems and applications running in ICS SCADA. Sometimes you do have a standardization. Some devices, they are not following some standard, security standard. Sometimes you do have downtime. You need sometimes in this we talk about management space. Sometimes you need to do some maintenance, okay, and the maintenance of the devices is a challenge because you need to turn down those machines, and they are vital for, let's say, for the human and the economy of the country, for instance. So you have to do some specific management in order to choose the appropriate time, how long those devices will be down for maintenance and so on. Sometimes you do have unsupported operating system and applications inside those devices. It is not easy to do real-time pen testing in production real-time. If you do have, for instance, devices and machines that are running and producing in the production line, and you cannot turn down those machines, it is not easy to do pen testing in those machines, because you might cause some, if you are testing, for instance, for a DOS, you might cause a DOS on those machines and they will stop, for instance. Sometimes you don't have enough time to remediate against any incident that can happen. Okay, for instance, you discover that you are under DOS attack, and you don't have enough time to take action, to take appropriate action to defend against DOS, remediate, and how can you deal with such attack because of, let's say, the sensibility of the environment you are working. Sometimes you do have share accounts, or there are no authentication between users. This can be also a challenge, which is categorized as the management. Okay, and sometimes we talk about the secure connection between IT and operational technical people who are used to operate those machines. Okay, when we talk about operational technology and information technology. Information technology are the things that are related to any type of cyber, okay, or IT, and you do have operational technology, which is related to, for instance, monitor and those devices that are using mechanical way to run or electronic way that are different from an IT. In terms of objectives, okay, so what are the objectives in any to protect an ICS SCADA with relation to the security? Okay, here as objective, when you secure an ICS SCADA, you make sure that in your as your objective is to keep the system functioning as possible, as much as possible. Okay, whatever the difficult condition you are facing. Okay, as much as you are under attack, for instance, you try to keep maximum the ICS SCADA running, not to be down, as we mentioned, because there are specific and critical infrastructure. This can involve, in order to make the things function and ICS functioning all the time, this can be done by the way of redundancy. Okay, when you do have critical devices within your ICS SCADA, like for instance servers, switches, modems, and field instruments, try to have a redundancy of those devices, because if one device fell down, whatever unintentional or intentional threat, at least you do have a replacement device. Okay, in order just to make, let's say, the device and the ICS SCADA function all the time. Okay, and also during a failure, when you do have something failure or attack, those devices should not cause unnecessary traffic on the ICS. That means you should not have extra information or extra messages running on the ICS SCADA system network. Okay, and that failure will not generate any unnecessary traffic within, because it will slow down, it will create an overhead in the communication and will slow down the process of the ICS SCADA system. Also, as an objective, we said that the ICS SCADA system should be designed. This is very important to with regard to this ICS, which is known as systematic degradation. إيش معنى systematic degradation? Is how can you move from a normal condition. When you talk about normal condition, معناه we do have a full automation. And everything is done automatic. This is normal condition. And in case if you have a problem, you will move from the normal condition into emergency condition. ايش معنى emergency condition؟ معناه here instead of having full automation, everything is controlled automatically by machines, by computers. When you go to the emergency condition, you will have operators, people who will interfere with, let's say, those machines, making less automation. Here we talk about a full manual status or no automatic at all. Like, for instance, I gave example, we go back to our example, which is the valve. Let's say you can control a valve of a barrage to control the level of the water automatically, remotely by computer. You can send command to close or open a valve. But in case of an attack, if an attack happens and you are no longer able to control the valve automatically and remotely, what you will do, you should have what is known that as a solution, systematic degradation. That means you should have a plan B to close those valves manually. This is what I talk a full manual status with no automation at all. That means you will send people, operators, employees, technician to that field, to the valve, and that valve should have some specific manual key operation where you can close it manually instead of closing it remotely with full automation, because now you have a problem and all the machines, all the devices that are part of your ICS SCADA should have this type of what is known as a systematic degradation. That means you will be able to move from a normal condition with full automation to emergency condition with less automation. Clear هذا يا شباب؟ Is that clear for systematic degradation? Yes, شباب? Can you hear me يا شباب؟ Hello? Faras, Muhammad, Ahmad?
Yes.
Okay, is it clear? Okay. Another protection objective is to provide systematic and practical way to detect any security event and incident. You should have at least in place in an ICS SCADA a way to detect anything that is unusual, unwanted activity or event should be detected automatically. Okay, so in order just to detect, for instance, let's say for instance you do have some failure on an ICS SCADA device. Okay, that failure should be detected automatically. It's not like you will discover it after a while. Okay, you should also, if you do have any DOS attack, you should detect it automatically. You should have in place some monitoring stuff to monitor the traffic and to detect any area where you do have, let's say, a huge bandwidth that is used. That means unusual usage of bandwidth. That means you might be under DOS attack, for instance, in order to take action. Okay. Of course, we do have other types of objective that you can have, which is availability, integrity, and confidentiality. This, let's say, these are the main objectives in any security system, included the ICS SCADA system. In terms of requirement, security requirement for the ICS SCADA, you need to protect the field instruments. Here we are trying to talk about the different, how to secure the different component of an ICS SCADA system. Okay, we said that one of the components of the ICS SCADA is the field instrument, included sensors, actuators, PLC, RTU. So these should be secured enough. Okay, in order just to provide security for the whole ICS SCADA. Now, how we can secure those field instruments? The security starts from the selecting the right device. When you go to set up your ICS SCADA system, and when you select those, when you go to purchase, for instance, actuators or sensors, you need to choose the appropriate one that is compliant with the latest security standard. You're not going to purchase some devices that are not complied with any security standard. So by purchasing from the beginning, when you select the devices, you should select the right one that complies with some security standard. And when we said for the security for the field instrument, it is from the starting point, from procurement to the installation, monitoring, and maintenance. And one of the attacks that have been found is you do have the attackers, for instance, they will set up a factory, for instance, for for making NIC, and those NIC are made with some Trojan horse inside them from the factory, and they are sold to, for instance, an ICS SCADA system company, for instance, and they are purchasing those NIC without having any idea that they have been, let's say, built with some malicious code inside them. Okay, and because you have bought those devices from this factory, and you don't know, let's say, the history of that factory and whether it is genuine or not, and that's why we are saying that when you talk about the field instrument, security should be from the procurement, from the first time. When you try to get those devices, you purchase those devices, you should make sure that when you purchase those devices are from a well-known company, for instance. It is not enough just to do that, even installation. Maybe during the installation of those devices, you have hired some people from the outside, and among those people, you might have some hackers who pretended to be engineer or technician, and they will install malicious, let's say, things or code or devices within those security field or field instrument during monitoring and maintenance as well. So all those field instrument security should go through the life cycle. Also, those field instruments should meet the core security requirement. For instance, at least you should have authentication on them, authorization, CIA. Okay, these are the core security requirements that should be present in those field instruments. Okay, and when we talk about, for instance, if you do have physical, you should provide physical security countermeasures to protect those field instruments, because those devices are put in the field in an environment. Okay, that means they should be protected physically. Okay, by having secure fences, gates. You can have combination of any electronic locks, physical locks, anything. Okay, you can have the CCTV that monitor access to those field instruments. Okay, so these are for the field instrument. Inside the ICS system control, you do have the servers. You have devices host, and you do have servers in that MTU. And those devices should be also well protected from any logical or physical attack. As we mentioned, we should have redundancy within those servers. We should have, in terms of high capacity link between the server, there will be some exchange between servers inside that control room. Also, we should have such a high capacity link that will resist against any bandwidth DOS attack, for instance. We should have a load balancing instead of having, let's say, only one device or one server doing all the operations. At least we should do some balance and distribute the balance through different servers in order to alleviate the load and not to create an overhead on some specific server against other servers. Failover mechanism, which is between servers and network component like switches and routers. That means if you do have any device, a switch or a router or a server that fell down, automatically the second replacement, because we do have redundancy, the second server will take place. The second router will take place automatically. Okay, there should be automatic action that will trigger when one of the device fails, the other one will take place. And also, you should receive appropriate configuration patch, okay, for those devices. If you have any applications or operating systems running on those devices, they should be up to date. Also, in the server, you can have multi-factor authentication just to harden the access to the server. You should have application whitelisting. You don't apply, you don't accept any application that is categorized in the blacklist. So only those known secured applications should be authorized to be installed inside those servers. And also, when I talk about the access control, okay, access control to those devices should be hardened. Okay, you should have a policy where you should define a secure identification, authentication, accountability, authorization, in order just to maintain those servers as much as secure as possible. Another security in ICS SCADA is the security of, which is physical, electronic, and physical security perimeter. That means the environment of the ICS SCADA should be monitored for identifying people who are accessing, who are getting inside that ICS environment, okay, and not to get to some restricted area, because even if you allow people, for instance, inside the building, let's say you are inside the nuclear plant building, okay, inside it there are some restricted areas, some very private area. You should control who has access to those restricted area. Okay, here we talk about, for instance, you can use to track any one who is inside that ICS SCADA environment, his movement, his activities within the building, who is accessing this and this room, for instance. Of course, you are using, and you should have some alarms in real time whenever it is required. If you find someone who has access restricted area, okay, without providing any authentication or any credential, you should send an alarm. And you should have what is known as unified security package, where you do have all those security measures working together: video surveillance, access control, perimeter detection. All those can be used together just to make sure that you are securing enough your ICS control room, for instance, for any offense. You can use, for instance, what is known as the man-trap techniques. Okay, for instance, when someone wants to enter your building, he has to pass through this man-trap, okay, and verify his ID before being let inside the room, for instance. Okay, these are all techniques. It's like, for instance, in some banks, you do have this man-trap where you get inside, and the security guy from the inside will look at your face, will register your, for instance, your face, take picture, then he will just click or press button to open a door for you to get inside it, in order just to block any unwanted, for instance, or a thief or anyone who wants to get access to the building. In terms of communication, we are talking about how you can secure all the communications channel that are used by the different devices, okay, to communicate between each other. When we talk about how can you manage the communication between devices, you need to manage the data that is received and exchanged through those channels, whether wired or wireless, in order to make sure that what you are receiving, for instance, you are receiving data from secure devices. Product hardware and software hardening. Here we talk about how can you, for instance, hardening the software. Okay, of course, when we say by securing the software that are used in ICS SCADA, we are talking about that the software that should be installed within an ICS SCADA system should be certified, licensed, okay, and it does follow some security standard. Should be patched with the latest security patches, for instance. It has been tested. It is a stable version that will not cause the devices to be down at any moment because of the failure of the devices. Okay, and of course we talk about how can you we secure the system itself. We do hardening of the system. If you do have any port open or any services that are not needed for the running of ICS SCADA, we need to turn them off. So we stop here. I mean, next time, inshallah, we continue with the few remaining slides, inshallah.